As promised, I'm going to continue with a series of videos of calculating strengths of solutions, but this time we're going to look at doing calculations, or the solutions, when we want the concentration in parts per million, or ppm. So when you're looking at concentrations in parts per million, you may have heard of a 1 in a million chance. Well, if it's a 1 in a million chance, or even if you haven't heard of that, you'd probably be pretty certain that it's a very small chance. In chemistry, very small concentrations are written, or can be written, in parts per million, which means that there's one part of that substance for every million parts of water. It might be equivalent to some teaspoons put into a swimming pool in terms of concentrations. 1 out of a million is very, very small. Well, for parts per million, one way to think about parts per million is to say that the mass is going to be in milligrams and the volume is going to be in liters. That comes a lot from the fact that a kilogram of water is a liter, and if you had a milligram, that's a million jumps, because from milligram to gram, you've got 10 to the 3 or 1,000, and from gram to kilogram, you've got another 10 to the 3. That makes 10 to the 6 in total. That's a difference of a million. That's kind of where that 1 in a million comes from. Anyhow, so the formula we need to use is concentration is mass over volume. So we will take a look here and go at an example or two. Example 1, Jane dissolves 2.5 grams of cleanser into 1,250 mils of water to clean a water jug. We want to know the concentration of the resulting solution in parts per million. So as soon as you see parts per million, you realize that it's M over V, not N or moles per liter, but mass over volume. To get that concentration, the mass must be in milligrams, so if it's not, put it there, and the volume must be in liters. And again, if it's not in liters, make it to be in liters. So we now look at a mass of 2.5 grams, and we look at a volume of 1,250 mils. Those are given in the question, mass, volume. Now, this is not in milligrams. We need to put it in milligrams. Well, there's 1,000 milligrams to a gram. Since the gram is bigger, we're going to multiply by 1,000 to get that into milligrams, 2,500 milligrams. Now, for a lot of people, that's obvious, but it's still nice to semi-explain it. 1,250 mils, to change that into liters, mils is the smaller unit, so you've got to divide that by 1,000 to get it up to liters, which would be 1.250 liters. With those units as milligrams and as liters, now we're ready to go and calculate the concentration for parts per million by making it M over V. So we take 2,500 milligrams and divide that by 1.25 liters. And when we take 2,500 and divide by 1.25, you get 2,000. 2,000 is our answer, and that is milligrams per liter, or 2,000 parts per million, ppm. Now, it can be sometimes more complicated because they're not going to give you the units in a very nice way. What if they give you moles and they don't want molarity, but they want a concentration in moles per liter? Well, we'll just have to convert it. Here we're given the number of moles, so that's N, 1.3 times 10 to the minus 2 moles of barium nitrate, and it's dissolved in a volume of 750 mils. So we convert that to liters, divide by 1,000, and you get 0.750. The question wants concentration in parts per million, so we need mass and volume. We do not have the mass, we have moles. So we're going to use the fact that mass is the number of moles times the molar mass, and we'll get our answer out. So we don't have a molar mass. We are dealing with barium nitrate. Barium nitrate is a barium ion, which is +2. Nitrate is NO3. It's a -1. You need 2 of them nitrates to balance that out. So you have a barium. So for the molar mass, We need a barium, which is 137.33. You have 2 nitrates, so you've got 2 times 14.01. And you've got 6 oxygens, so 6 times 16. Okay. And to add all that up, we have 137.33. We're going to add 28.02 and 96. Gives us 261.35. That's grams per mole, which is our molar mass of barium nitrate. Once we know the molar mass of barium nitrate, we can figure out the mass that we have present, because we have a small number of moles, 1.3 times 10 to the negative 2, and we multiply that by our 261.35 grams per mole, and we'll see what we get. So we take our answer, multiply by 1.3, exponent negative 2. Don't hit the multiply button when you're putting scientific notation in. You get 3.397, or 3.4 grams. Well, 3.4 grams isn't how you want your mass when you have it in parts per million, because you want it in milligrams, and the volume we already converted to liters. So we multiply this by 1,000 to get it into milligrams. Quite obviously, you get 3,400 milligrams. And these examples aren't spectacular, I notice now, because they're very big concentrations. You have 3,400 milligrams divided by 0.75 liters. So we take our 3,400 and divide by 0.75, and you get 4,533 and a whole pile of threes parts per million, okay, or around 4,500 parts per million. All right, so I hope that helps you guys out in your calculations of these problems.